Production decision modeling. We start with the production decision modeling. The model of the production decision aims to determine the volume of goods and service supply to the markets by our industries, the two industries, and the volume of input and factors demanded from the market by these industries. In this regard, industries face two constraints. The first constraint is the technical constraints in the production system. This is translated through the choice of the mathematical functional forms and the related parameters or structural parameters. The second constraint that they face is the economical constraints through the competitive prices. Here, industries are price takers on the factors and product markets. To produce the good or the service available in our economy, industries combine production factors, labor and capital, and input, good and service. For instance, to produce rice, one needs labor, hours of work, capital, for example, land and equipment, and one needs goods, or here, think about seeds in our rice production system. And one needs service also, for example, transportation service to move the seeds from the market to the farm. Specifying the relationships among these different production elements is important in the modeling process. In general, a layered relationship is specified. Here, the first layer combines value added and total intermediate consumption in the production of good or the production of service. The second layer combines capital and labor in one bundle called value added and good and service in another bundle named total intermediate consumption. Starting with the first layer, a complementarity between value added and intermediate consumption is assumed here. For instance, to produce a given quantity of rice, a farmer combines a volume of inputs, seeds and transportation, and a certain volume of factors, labor and capital. Then when you double the quantity of rice production, then you double the volume of inputs used and you double the volume of factor used. Therefore, it is assumed here that inputs and factors are combined in the fixed proportionality. The fixed proportionality also is referred to a Leontief functional form. The mathematical expressions at the bottom of the slide specify the production of the good industry on the left and the production of the service industry on the right. The top equations specify the relationship between production, XS, and value added VA in a fixed proportionality relationship or functional form, with V being the related parameters of this functional form that we have selected. The bottom equations specify the relationship between production excess and total intermediate consumption, here also in a fixed proportionality with the parameters that are associated to this functional form. Here it's I. Moving to the second layer, a complementarity is also assumed between good and service in total intermediate consumption. Another example, still with our rice production, a farmer combines a given quantity of seed and a volume of transportation. As previously stated, when you double your production quantity, then you need more seed, then you double your seed in this functional form, and also you double your need of transportation, which is referred to the fixed proportionality assumption. The mathematical expressions here at the bottom specified how goods and service input are combined in total intermediate consumption for the good industry on the left and the service industry on the right. The top equations specify the demand for the good input, CD, ID, index it by G for good, which come from the derivation of the profit maximization of industries. So the IGS are the related parameters. I for input, G for goods, good commodities, and S for for service industry. And IGG is the equivalent for the good industry. Bottom equations specify the demand for the service input, ID. Here also the index S is for service, and this demand is derived from the maximization of profit by industries. And the parameters ISG and ISS are related to this functional form. Once again, I is for input, S is for service commodities, the first S, and G and S for goods industries and service industry. Remaining at the second layer, a substitution between labor and capital is assumed in the value-added generation. Giving you another example, still being in our example of rice production, a farmer here combined hours of labor and hours of use of machinery or equipment. Here, the farmer can substitute hours of labor with hours of machineries, depending on the variation of labor and capital costs. The mathematical expressions at the bottom specified that substitutions between labor and capital factors in the value added of good industries on the left and the value added of service industry on the right. The top equations define that relationship, while the bottom two equations specify the demand for labor and capital by good industry and service industry derived from the profit maximization problem. Here, alpha and beta are the parameters associated with the functional form, and they represent the share of labor costs and capital costs in value